This is Euclid Book 3, proposition number 14, and we start out with an equal angular and equilateral pentagon. And you know how to draw one of those, so we're not going to go into that. The next thing you're going to do is you're going to bisect angle BCD and bisect angle CDE, which is right here. Okay? And when you do, these two lines are going to come together at a point, and that point will be F. And wherever these 2 points come together, you're going to extend a line out from F to B, and F to E, and F to A. Okay? And then what you're going to do is you're going to figure out real quick that FB bisects CBA, FE bisects DEA, and FA bisects BAE. Okay. Now, if this is an equal angular and equilateral pentagon, what you're going to first find out is that BCD, angle BCD, and angle CDE, this one right here, CDE, these two angles are exactly the same size. Then you're going to say, okay, because those two angles were bisected, then we can go on to say that angle FCD is 1/2 the size of BCD, and CDF, that's a CDF right here, it is 1/2 the size of CDE. Now, if you have two angles which are exactly 1/2 the size of two equal angles, then we can go on to say that angle FCD, this one right here, is exactly the same size as CDF, which is right here. And having said all of that, because of Euclid Book 1, proposition 9, which talks about how to bisect an angle, because we've said all of this, we can go on to say that line FC here is the same size as line FD here. Now we can go on through a chain reaction here. We can say, well, okay, CDE was bisected by DF, and DEA here was bisected by FE, and so let's see here. We can go on to say that FDE and FED are the same size because they are 1/2 of two equal angles. Therefore, FD and FE are the same size. And we could go on here. FE and FA are the same size, and FA and FB are the same size, and so on and so forth, all the way straight down the circle. All we have to do is use Euclid Book 1, proposition 9, and Euclid Book 1, proposition 6, and we can prove all this. Therefore, we have 5 lines that are equal in size. These are now going to become radii of a circle. And what you do is you put your compass, the centermost part on F, the outermost part on either A, B, C, D, or E, draw it around, and you will circumscribe a circle around this pentagon, which is what Euclid wanted you to prove in the first place. Alright, I will tell you more in a future video, so stay tuned.